was super short. So in chapter 7 we had 1, 2, 3, and 5. I think is all we did. Now, if you think about what section 1 was, that was just cross multiplying, solving for x. Okay, that was what we were doing there, and which you had to be able to do here and here. When we got into 2 and 3, this is when we started talking about similar figures, talking about what does it mean to follow a similarity statement, knowing how to work with our letters. It also talked about ratios. So, for example, we have ratios of the angles in a triangle. If I want to talk about ratios of the angles in a triangle, for example, look at number 1. It says the ratio of the measures of the angles of a triangle are 8, 3, and 4. What are the measures of the angles? Well, what's the trick if you have the ratios of the angles being 8, 3, 4? Remember what that trick was? What was that? Exactly. Remember, if you're talking about the ratios of angles, you know that you have a triangle. If you have a ratio of 8 to 3 to 4, that means that there's some common multiplier to each one of those numbers. That common multiplier is what we don't know. It's 8x, it's 3x, it's 4x. But when you put those three values together, when you put those together, all we have to do is add them. What's 8, 3, and 4? 15. Good. So we get 15x, and like you said, Ms. Spots, what does that have to equal? Very good. Josh, I think you already divided that out in your head there. What did you get for that one? 12. Good. So you get x here, that common ratio, that common value, that common multiplier is 12. What do I do with that value of 12 to figure out my angles? Exactly. All I have to do is substitute back in. So you'd have an 8 times 12, a 3 times 12, and a 4 times 12. What was that? 48, 36, 6, and 96, I believe. Hey, boy, oh boy, that looked a lot like a question from the quiz, didn't it? What changes about the ratios of sides? Exactly. When you talk about ratios of sides, they don't necessarily add to 180. They add to whatever they tell you they add to. Okay? So try number 2 here real quick, and we'll check it in a second. Yes, sir. What's that? Sorry. Yeah, you can find the size. I think it's what it says, right? Yeah, I'm measuring each side. So basically, it's the same exact problem, except you're not adding to 180. In this case, we're adding to 30. So you get 9x, 12x, 15x. Well, what do we get? 9, 12, and 15 is 36. All right. Yeah, 36. Oh, it's supposed to be 5. Oh, did I write? Thank you. Hey, what happens if you did that and you wrote 9, 12, 15 and you did everything correctly? You probably just get a giant frowny face. So let's see. This would be 17. This would be 26. Correct? Yeah. 5. Which gives you sides of 45, 60, and 25. I guess you would have known right away if you did a 15 and you substitute back in. You'd know if you had a much larger side than you probably should have. Probably should have caught that. Scale factor. How do you find scale factor? Not necessarily. That's when you're solving for the value. Scale factor is the ratios of the sides. So it depends on how you set it up. When you're talking about scale factor, you can go from, if they're saying from figure A to B. So I'm looking at the one on the left to the one on the right. So the one on the left, if I want to find the scale factor going from A to B, I just have to make a decision which of the sides I want to use for the scale factor. Do I want to use the 36 or do I want to use the 25.2? All right, use the 36. Now, of the two given sides that they gave you, is the 36 the larger or the smaller of the two? It's the larger, which means which of the two on B should I use? And why is that? Exactly. And what do you do every time you have a ratio to get the scale factor? Simplify. Put in the calculator, press it. With fraction bar, it does it automatically. If I do this by hand, though, I get what? 18 over 10, 9/5. So the ratio would be 9/5, or 9:5, or if you wrote it out 9:25, any one of those is fine. Now, if it asks going the other direction, what do? You put the value of B in the numerator versus the other one. Don't do that. What's that? Hit the fraction of the decimal. That's how it works. You should. And that's one of those things you can be on that one. Try the next. Do the next three. We'll check in a minute. You got a scale factor. You've got to solve for x's. Excuse me. Notice those two that you're solving for x. 5 and 6. What are they giving you? What are they giving you to start? Similarity statements. So B to A. Does it matter which side length I use to find the scale factor? I'm going from B to A. This time I'm going to say it's 9 to 12, which is 3/4. I just picked the two smallest side lengths. That's really the only thing you have to be cautious of when you're looking at the diagrams, guys, is making sure you're picking, if you pick the largest, make sure you pick the largest on the other. So it's 21 to 28, or the smallest, 9 to 12. There's not much thinking there, just got to be careful. Then when you get going into your similarity stuff, you've got what? KL, LJ, JK, BW, WU, UV. And then it's a matter of filling in what you know. I've got KL, that's a numerator. I've got KJ, that's also a numerator. Then I have WV, right here. And then I have UV, which is right there. And like we've done before with these, as you get going, do you have to simplify the fraction right away, or could you use the larger numbers? You can use the larger numbers, it's just, you have a calculator, it's not a big deal. But I would just simplify it. I know that 25 over 20 is 5/4, just because it's easier, especially if you're trying not to use the calculator. So you cross multiply. Excuse me. We cross multiply that, distribute. Uh, 4692, I believe. Variables on both sides of the equation, you always want to pick out the little guy. Move the 10x, same time add the 92. This up a bit. 6x then is going to be 102. Where are you at, Shaq? Oh, yeah, you know what you did? All I did here differently is you went to the, were you just reading off the letters? Okay, so you went KL was 25 for that numerator, which meant that the BW was your 20. Oh, careful. What you did is you did your 25, but you put the next one, the 4x minus 3, right next to the denominator. Whenever we're setting these things up, you want to make it in the right output state because these two should be approaching one another. But anytime you've got a ratio, you can switch them. So this should have been 25 over 20. Because when you set these things up, the lettering tells you that those two should match. Because going from the triangle on the left to the triangle on the right. It just so happened that, I gotta get some super glue. Remember when we did this, 2/3 equals 4/6? If I flip those, it was still okay. You did the right, wrong mistake, if that makes sense. Oh, I don't know, I haven't gotten that one right. But what I would suggest, and this is, I've been trying to instill this idea, write these out, because what'll happen soon is that sometimes you're not just going to have two sides, you might have three mixed together. You have to be really careful about which one goes with what. Because with two on both triangles, you can kind of almost get lucky with it, kind of like what you just did there. But if you have three parts to it, you run more of a risk of getting it. Okay, so just write it out. Okay, so write out for that next one there real quick. Just take a second, just rewrite your letters. Don't erase your work yet, but write your letters to see if you matched it up correctly. If that makes sense. You see what I'm saying? Try that real quick. What's that? Same deal with the next one. As you go through them, remember, what you want to do is write out the letters first. It's always the best bet to go through your lettering. Especially then, as you get going into the ones where you have to actually label what goes where and all that, what letters match, you'll be less likely to mess something up. So if I'm checking out the next one where it tells me my letters of N ML I know that MM, ML I know that has to work. I just look at what I have. Remember, this only takes like 5 seconds to write out, 10 seconds. And it kind of alleviates screwing up. I have an ML, which is 28, so that's a numerator. I have an NL, which is a numerator, 3x minus 1. I have an LR, which is right here, which is the denominator. And then I have an x plus 7, which is an LS, right there. So Shai, did you have it matched up correctly?
No.
But if you wrote the letter, I mean, again, you made the right-wrong mistake. So just be very, very careful because remember, I think on the quiz we had one that was like this, but the lettering on the other side was flipped, so you couldn't have done what you're doing because then it would definitely would have been wrong. So just make sure you write your letters and you'll be all right. 28, 24, I can simplify those both out by what? 3, I believe? No, 4. Excuse me. 4. It's one of those numbers. If I go by 4, then that gives me what, 7/6? And the only reason I'm doing that is just a smaller number for me to multiply through. You don't need to. So you get 6 times the quantity 3x minus 1, 7 times the quantity x plus 7. Was it 18 minus 6? So move the 7x to the left, move the negative 6 to the right. We get, what was that? Subtract out, that is 11x. It's nice when numbers work out cleanly. All right. Finish this one out for tonight. We'll go through it tomorrow. I've got another little setup of like similar stuff to this that we'll do again tomorrow to prep through. I'll dig out a couple extra of the quadratic ones, but to be honest with you, I'm not going to make you anything with that leading term that's not equal to 1. That's just flat out mean, especially on a test. So that might be a bonus question type thing. All right. Yes, ma'am. Which one? So, yeah, just right out. I So what happens here, if you're looking at the two triangles that they have a scale factor of 4 to 3, that means that yeah, wrong side. So what happens here is we talked briefly about this in 7.2. When we set up the ratios of sides before, when we talked about perimeters, we said that the scale factor of the sides and the scale factor of the perimeters were always the same. So if the scale factors of the sides are 4 to 3, that means the scale factor of the perimeters will also be 4 to 3. So what I do here is I figure out what is the perimeter of the triangle on the left. The perimeter of that's going to be 13, 22, and 29. So it's 45, 64. So the perimeter here is 64, and the perimeter here is, I don't know. So if I use the scale factor going from left to right, instead of writing it as a colon, I can write it as 4 to 3. You okay with that? The perimeter on the left is 64, what's the perimeter on the right? And then you just cross multiply. It will work always like that for perimeters. Yes, sir. Each individual side? Absolutely. Yep. Yep. You can do that too. 13 over something is 4 to 3. 22 over something is 4 to 3. If you could have done all that, that's 3 things, plus then you have to do an adding thing. So if you remember that the perimeter has the same ratio as the sides, it's just one less step, or actually a couple less steps. Yes, ma'am. What'd you get? 48. Anybody else get 48 for that one? I think that's right. Sounds right. Okay. That's one of those trick things. I wouldn't say a trick thing, but it's one of those things you do see from time to time on this. As we get into surface areas and volumes, we'll also go back and talk about ratios of sides, perimeters, areas. It all comes back. Thanks, guys. See you tomorrow. I know you don't like them.